Good afternoon, everybody. Welcome to Physics IGCSE again. And today we're busy with Hooke's law. We're talking about springs and stretching things. So before you carry on, I want you to pause this video and go and study section 5.3 and attempt the questions 5.3, 5.4 at the end of the section, please, and then we will come back and discuss them. Okay, all right. So in this section, there's a couple of things that's important. First of all, Hooke's law. If the force is actually the load, okay, in newtons. This K is the spring constant, and this is newtons per centimeter, or newtons per meter, or newtons per millimeter. Any length you like, but you've got to make sure what length they're using, and then you have to stick to the same length. Same, the extension. If this is in centimeters, this must be in centimeters. The extension is if the spring is originally like 50 centimeters, then the extension is what we are measuring, which is the extra little bit here, which might be 4 centimeters. So you've got to always know what this is and what this is, and you've got to subtract the one from the other. So because this is the extension, we're not putting this on the graph, we're putting this on the graph. Okay, so all right. The spring constant. This is the spring constant. Yes. Just be very sure it's newtons per. I'm talking centimeters now, but it could be any length. Newtons per centimeter. Okay. This graph is written in a special way for Hooke's law. It's not the normal way round we write graphs. We would have said x is equal to f is equal to some other slope, let's call it capital K x. That doesn't look right. The graphs on the linear motion would have been in the form of y equals mx, where this is the slope, this is the x-axis, that's the y-axis. This graph is written the other way around, so don't change it, otherwise your k's units are not going to be right. Okay. Hooke's law says that this load, we can write it like this: the load, which is the force F, is proportional to the extension. Which means that if this load doubles, then this will double. If this halves, then this will halve. If this is 10 times, then this is 10 times. Which means that this graph is a straight line. All directly proportional graphs are a straight line. Like this, or like this. So if this doubles, then this will be double. So, directly proportional. And that is what Hooke's law states, that the load is directly proportional to the extension as long as the limit of proportionality is not exceeded. If you stretch the spring too much, you'll get that effect. Okay, and then the spring won't come back to its original length, which was this length here, which we've said was 0, but this is because we're subtracting. So this spring, if you exceed that, you damage the spring and the steel starts to stretch, and when it comes back, it doesn't go all the way back to where it was at the beginning. Okay? Alright, let's just quickly work through question 5.3. Question 5.3, the question is the load is 2.5 Newton. Okay? And the increase in length, which means, increase in length means it's the extension, is 4 centimeters. What load would give 12 centimeters? So 2.5 gives 4. What could give 12? What did we multiply to get from 4 to 12 centimeters Newton? We multiplied by 3 times 3 gives us 12. So we must multiply by the 3 because times 3 because it's directly proportional. And 3 times 2.5 is 7.5. So the answer is 7.5 newtons. We're just not even using the actual equation, we are just using the proportionality, which is basically the same thing. Okay, that's question 5.3. 5.4, question 5.4, the spring is unstretched. It's best to draw a little sketch here until you are sure of what they mean. Unstretched is 12 centimeters. 12 centimeters. So this spring, when you buy it in the shop, it's 12 centimeters long. Then they stretch this to 15 centimeters. So this length here is 15 centimeters. You're hanging a weight on it. Okay? They don't tell you what weight you're hanging, but they're telling you the spring constant is equal to 8.0 Newton per centimeter. Okay? So, what was the extension of the spring? The extension of the spring is the difference. Okay? 15 minus 12, so the extension is this length here, which is 3 centimeters. You've got to be very careful when you're doing these things, not to use the original length of the spring, but only the increase in length. So we can now just substitute that into the equation if we want to. So we want to know what load, there's our load, the force. That's it. The load, therefore the load is equal to the spring constant, which is 8, multiplied by the extension, which is 3. Therefore, the load is equal to 8 times 3 is 24 newtons. Very easy, not difficult. And now you can do question 5.5 at the end of this section, and then go to the end of chapter in the course book and do question 2, 6 and 7. Thank you.